Okay, and let's go over the topics on the test after I put the date on this document. Okay. And let's go through the topics, and then I'll take any questions you have on anything, okay? 1 through 7 is on conic sections. And what I would do, for example, I would, given a typical problem would be a parabola question maybe, you know, something like x squared minus 6x is equal to 12y, something like that. Find orientation. And all it means is up, down, left, right, okay? That's all that means for the parabola. Okay, up, down, left, right. I would ask you to find the vertex. I would ask for a focus, possibly a directrix. Those are the kinds of things, okay? So what you have to do is put it in the standard form by completing the square. Find what P is, the distance from the vertex to the focus and the distance from the vertex to the directrix. Okay? That kind of a thing. Okay? I would give you something like this. Something like this. And I would ask for, what the heck do I ask for here? Center and radius of the circle. Well, these should not be difficult. Find the center and the radius. Okay, everybody else say, yeah. Complete the squares, do the center and radius. I would give you something like this. Ooh, this one's nasty, though. All right, here we go. I don't know. I'm just going to make this up. I'd give you this. I'd ask for the orientation in the center. Now, orientation on this hyperbola is either left, right, that's one choice, up, down. Just by looking at this, what orientation would this hyperbola have? Left, right, because the x squared is positive, okay? And the center, okay? You find the center by completing the squares, okay? So just be careful with that. The thing to be careful about is this minus thing in here. But that's all I'd ask on the hyperbola, and that's what I would ask. Given possibility of an ellipse, let's say, add 9, something like this. I would ask you to find semi-major. All right, ask for the center first, but I've already written semi-major. Semi-major, semi-minor axis. That's the length of each. The center of this ellipse. That's pretty much it. Okay. That's what I would ask you for. So you complete the squares. Okay. Recognize that when you divide, set it equal to 1. Each is over, 1's over a squared and b squared. The a squared is the greater of the two. So a is the length of the semi-major, b is the length of the semi-minor. That's the kind of thing I would ask for. The center would be the HK after completing the squares. Okay. That's the first set. Any questions on this? This basic kind of stuff on the conic sections. Okay. Omar, you also know this? Liam.
You probably know this, but the difference between the circle and the ellipse is the coefficient of your squared values.
Are the same. Yeah. They have to be the same sign. Okay. And if they are different coefficients but same sign, that's an ellipse. Same sign, same coefficient, that's a special case of the ellipse. That is the circle. Okay. All right, next section. This is 8 through 12. This is on parametric forms. What's that? Oh.
Would that mean that like a circle is an ellipse, but
Yes.
ellipse is not a circle?
Not all ellipses are circles.
Right.
Yes.
And like rectangles and squares and stuff?
Yeah, and that kind of thing, a rhombus and things like that. Yes. You got it. Rhombi. Yeah. Parametric forms. Okay. I would give you, what do I give you here? I give you x and y in terms of theta, say. X is a function of theta, y is some function of theta. And I would ask for the orientation. Now, when you're talking orientation here, what you have to do is increase the parameter, okay, and see where the direction is. It depends on the shape. You may have an orientation that's clockwise or counterclockwise. You may have an orientation that's left-right, okay? But increase the parameter. Start the parameter somewhere. Normally you start at 0 and increase the parameter. You should be able to eliminate the parameter. Okay. Put it in. Yeah, it's right here. It's on this paper right here. No. Eliminate the parameter, and the general way to eliminate parameters is to solve for the parameter in one equation and substitute it into the next. But with the trig functions, we've got a shortcut. We take advantage of the Pythagorean identities with the trig functions. If you got sines and cosines, isolate them, square each, add them up. And same with tangents and secants, okay? You want to take advantage of the Pythagorean identities, which are going to be there on the wall, so.
Yeah, we can't erase them.
No, I know, it says it. All right, it says it right there, so I'm not going to erase it, so there you go. So eliminate the parameter.
This is what I needed in Calc too. That's all I needed.
Is that, yeah, well, yeah.
Would it change the world?
Yeah. Change the GPA, maybe, yeah. All right. I would expect you to be able to find dy dx, okay, in parametric form. And believe it or not, find the second derivative as well. Okay, so be careful with that. Oh, and then set up the integral for arc length. I'm not going to ask you to do the integral, but set up the integral for arc length. Okay. If it's in terms of t, if it's in terms of theta, that's clearly a theta there. Okay. That's the integral I'm talking about, okay? That's 8 through 12, 13 through 20.
What does 13 through 20 mean?
What does it mean?
What's it referring to?
The questions on the test.
Oh, okay.
Yeah. Question 13 is going to start the polar equations, and there's a section, there's two different sections. I'll give you two different polar equations, but it's 13 through 20 on polar forms, polar equations. Okay. Geez, I would ask for find symmetry. And you should by now recognize that if we've got a polar equation involving cosines only, we got symmetry with respect to the polar axis. If we have one involving sines only, we got symmetry with respect to theta equals pi over 2. You should be able to find symmetry. You should be able to identify the graph. And what I'm talking about here are circles. Okay. R equals cosine theta, R equals sine theta. Actually, it's a rose of a single petal, but it is a circle. You should be able to identify roses and limison and a cardioid. Okay, it's going to be one of those. You should
Third word there?
limison. That's an accent segu, or no, that's an accent. Wait, it's not an accent circumflex. That's this. That's an accent sedia, right? Accent sedia.
Would it be French?
What's that? Yeah, it is. It's a French word, sedia. I guess it is. Accent.
Aigu is like.
Aigu is that. Grave is this. Yeah. Circumflex is this, like L'Hôpital's rule. That's an accent circumflex. They're all French for some reason. I guess the French have a thing for making. I don't know what the heck the reason is. Yeah. Identify the graph. What else do you have to do? You have to. Okay. You have to find you have to change to parametric form. Okay. Wow.
Is that different from rectangular form?
Yeah, that is different from rectangular form. We needed this when we found dy dx of a polar equation. In order to find the derivative dy dx and the slope of a tangent line of a polar equation, what we had to do is convert it to parametric form first, and then find dy dx by finding dy d theta over dx d theta. So you should be able to do that. So you should be able to convert to parametric form, and you should be able to find dy dx. Okay? That's the slope of a tangent line. You should be able to find the slope of the tangent line at the pole. Jeez. Like I said, I'll do any questions you want to do in a second. Find the tangent at the pole. And you do that by setting r equals 0. You find the theta that causes r to be 0. That theta, whatever that angle is the equation of the tangent line to the graph at the pole. So if that graph hits the pole first at 30 degrees, pi over 6 radians, the equation of the tangent line to the graph at the pole is theta equals pi over 6. Okay, that would be that line through the pole with that slope. Okay, and that would be it. Wow, symmetry, graph, slope of the tangent line at the pole. Oh, and the integral for area. Holy mackerel. What the heck?
You mean you gotta know stuff in this thing?
Whoa, I guess. This is ridiculous. The integral for area, and do I ask you to actually do it? No. You don't have to do it out, but you do have to know that the area, where am I here? You can see that. Area is equal to 1/2 the integral r squared d theta. Okay? That's something I derived yesterday, I guess. Oh, boy. Whew. What a test. You can be here for weeks. All right.
You have to drop.
What's that?
You have to drop.
Oh, you may have to, yeah. Yeah, Wednesday, I expect maybe 2 or 3 people left, yeah. All right. All right. I'll do any questions you want to do. What you obviously should do is maybe confine your questions to these topics, which are of most interest to most people, but I'll do any questions you want to do. So, what was your question? Arc length.
Yeah, can we just do?
Yeah, let's do an arc length one. The arc length one is in a parametric form, so if you're given something like this, let's say x equals t squared, and let's say y is equal to 2 cubed. Find the integral for arc length. Let's have t go from 0 to 1, okay, over that interval. So here you go. The arc length is equal to the integral from 0 to 1, square root of the derivative dx dt squared, 2t squared, plus the derivative dy dt, 3t squared, squared dt. That is one nasty integral. I would not expect anybody to be able to do that integral. although it is doable with a trig substitution with tangent, because you take a t squared out as a t. Ooh, that may even actually take a t squared out. You get a 4 plus 9
Yeah, let's do
t squared. You could actually do that. It's a u to the n form. Okay? Watch this. This is kind of cool. When you multiply this out, you get 4t squared plus 9t to the 4th. You take a t squared out as a t. Look at this. Wow. Pretty cool. Now what? A simple u to the n form. U is 4 plus 9t squared. The du would be 18t dt. Multiply by 18 and 1/18th, you get 1/18th. The integral 0 to 1, 18t, 4 plus 9t squared. Okay, u to the n form, so it's 1/18th. This is your u to the n, 1/2. This is your du, so it would be 4 plus 9t squared to the 3/2 times 2/3 from 0 to 1. Wow, what a cool problem. 2 goes in there now. We get 1/27th. Substitute in 1, you get 13 to the 3/2. And when you substitute in 0, you get 4 to the 3/2, and that's 8. And that is the exact arc length of that function defined parametrically.
I
Whoa.
think it's so good, you should put the exact same one on the test.
Maybe I'll put this one in. I think I could. All right, maybe I will. David!
So for us to just find the integral, the problem stops at,
Well, I don't know if I have this or this. One of these two steps. Probably something like that. Maybe this one. Well, let's say this one. It stops there. Okay. All right, what else you guys want to do? Anything you want to do? You name it. Any questions at all? Yes?
Just like simply going from rectangular to parametric form.
Rectangular to parametric. Oh, in that direction.
At least I asked a lot of them.
Yeah, there's a couple. Yeah.
Really?
Yeah.
All right, you got it. For example, like y equals x squared plus.
Yeah, the one that they have is just y equals x squared. I think.
Oh, well, I'll make it this. Okay, and you want to go to parametric form? How about this? Let x equal t. Y would be t squared plus 2t plus 3. Done.
So your x always just equals t.
If you got y in terms of x equals t always works. Okay? Now, it depends if they give you some constraints. They say, okay, the orientation has to be this way or that way, then it may be a negative t or something else. So you have to do something else. But that's basically it. I'm sure I don't have anything like that on the test. But on the homework, there was problems like that.
Yeah.
What was wrong with this? Why couldn't you just do it this way?
I forgot.
Oh.
What about rectangular polar?
Rectangular to polar? Let's do it.
X squared plus y squared equals 9.
All right, let's do it. X squared plus y squared equals 9. Let's do it. This is in rectangular form. How do you go to polar form? Well, x is equal to r cosine theta. Very nice. Y is equal to r sine theta. Very nice. So we get r squared cosine squared plus r squared sine squared equals 9. Factor out an r squared. Sine squared plus cosine squared is 1. Oh, that's up there. Oh, and then they put it down here as sine squared equals 1 minus cosine squared. That's interesting. But whatever. This is 1. R squared equals 9. You get r is plus or minus 3. Yeah, go ahead.
You can just go straight from x squared plus y squared to y squared.
You know what? That's better than what I just did. Okay? You're absolutely right. This is a plus or minus 3, but the minus 3 is just redundant. R equals 3 takes everything anyways. But his suggestion is right on. X squared plus y squared is r squared, and go directly to here. Good call. The better choice right there. All right, what else you got? Yes?
Same problem, but we had like negative 12, 5 and convert that to
Negative 12, comma 5, yeah?
and convert that to 4 or 14.
Convert to polar. Convert to polar. Let's take a look. Convert to polar. Negative 12, 5. So we're over here somewhere. We'll make it here. Okay? And we want to convert to polar. To convert this to polar, what we have to do is find an r and a theta. Well, there's r, and here's theta. Okay? That's what we have to do. Well, what's r? R is equal to the square root of negative 12 squared plus 5 squared, 144 plus 25, 169, which is 13. So r is 13. What's theta equal to? Theta is the inverse tangent of y over x. Okay? I don't know what the heck that is. Inverse tangent of negative 5/12 is, I don't know, whatever it is. It is. All right? And so to convert it, the answer would be 13 and inverse tangent of negative 5/12, whatever that is, which I don't know what it is. So you'd have to do it on a calculator, and WebAssign wants it to like 3 decimal places or some other thing. That's what you do. You just do it on your calculator. Just be sure that you get an angle that puts your point in the second quadrant here. Just be careful with that, okay? Just be careful. Because your calculator may give you an angle that puts you down here somewhere, all right? And you may have to add pi radians to get it over here, all right? So be careful of that. All right, what else you got? Yeah, go ahead.
So I was stuck on one of the homework problems, and it's it gives you the rectangular coordinates, so like negative 3, 4.
Okay.
And then obviously you plot that, but then it asks you to find 2 sets of polar coordinates for the point 0, less than or equal to theta, less than 2 pi.
Oh, in terms of 2 pi, yeah, okay, so we got negative 3, 4.
I was confused about like the smaller, or how it's calculating the theta value, because I looked at the solution.
All right, and that's reasonable. Let's take a look at this. So it's negative 3, 4, is that the point?
Yeah.
Negative 3, 4. There it is, okay? So you got negative 3, 4. Here, okay? This is your theta. R is obviously 5, like you said. Okay? And theta is inverse tangent, okay, y over x. Okay, now, this is a little tricky here, because what about the inverse tangent of negative 4/3? If you do this on your calculator is going to give you an angle between negative pi over 2 and pi over 2, because that's what inverse tangent is defined to be. When you define the inverse trig functions, okay, I'm going to take this away here. When you define your inverse trig functions, this goes back to Calc 1 and Calc 2, what happens is this. Let me start with sine. Here's sine. Okay? All the trig functions are periodic, which means what? They fail horizontal line tests. They pass vertical line tests because they're functions, but they fail horizontal line tests, which means they're not one-to-one functions. What does that mean? That means that their inverses are not functions, because when you flip this around the line y equals x and get an inverse function, it's going to snake up and down the y-axis. This goes along the x-axis. That's going to go up and down the y-axis. That's not a function. To be a function, it has to pass a vertical line test. So what do you have to do? You have to restrict the domain of your sine. So over that restricted domain, you have a one-to-one function. So it passes a horizontal line test. Now, what restricted domain should we use for sine? Well, we should use this for sine. Our restricted domain for sine should be the x's from negative pi over 2 to pi over 2. our y values, the values of the function itself, are going to be from -1 to 1. Our domain consists of angles from negative pi over 2 to pi over 2, the result of which is a real number from -1 to 1. Now, when we take our inverse sine, the arc sine function, the x's and y's swap. The x's are going to be real numbers from -1 to 1, and the y's are going to be angles from negative pi over 2 to pi over 2. Your calculator knows this. When you give your calculator this problem to do, what does it do? What does it give you? It gives you an angle between negative pi over 2 and pi over 2. It gives you an angle in the fourth quadrant. It gives you the angle as negative pi over 6. Your calculator knows this. It gives that angle as negative pi over 6 or negative 30 degrees if you're in degrees. Okay? So what happens when you turn around and do the tangent? It turns out that the tangent has the same domain as the sine, negative pi over 2 to pi over 2. So what does your calculator do when you give it that problem? This problem. Okay? It gives you an angle, okay, in the fourth quadrant, because the tangent is defined the same way as the sine. Okay, let me show you here. Here's the tangent with its vertical asymptotes at negative pi over 2 and pi over 2. Okay? And it continues its periodic function. Okay? This is the restricted domain. The restricted domain of tangent is from negative pi over 2, don't include pi over negative pi over 2, to pi over 2 and don't include the pi over 2. The only difference is you don't include the endpoints here on the tangent. Your range of the tangent is negative infinity to positive infinity. So your inverse tangent function, your x values, okay, on the inverse tangent are the y values here, which go from negative infinity to infinity. Your y values, the result of taking the inverse tangent, are angles from negative pi over 2 to pi over 2. Okay? So, when you give this to your calculator, inverse tangent negative 4/3, what does your calculator do? It gives you an angle between negative pi over 2 and pi over 2. Well, that may not be the angle that we need to get over here in the second quadrant, and it isn't. So, and plus, not only that, they want an angle from 0 to 2 pi. So, if you're getting this angle over here, how do you get over here? You add pi radians to it. When you add pi radians to it, you're going to get that angle over there. So sometimes you're going to have to take your answer that your calculator gives you and add pi to it to get an angle that WebAssign wants. So who asked this question?
So
Yeah.
It was asking for two different theta values. So the first theta value would be with pi added to it.
Yes.
The second one,
The second one, with a smaller r they want. So what they want you to do is have r as negative 5. Yeah, that r is negative 5, but then you have to take this negative 5 here and take it and put it on the other side. So what you need is this angle here at negative 5, because if you use this angle at negative 5, you get the point in question. So what is this angle? Well, that angle is a negative, whatever it is. It's what you get from this. Okay? So what you're going to have to do there is use, but this angle is not good. So you have to add 2 pi to this angle to make it a positive number. Okay, so here's what you got to do. You do this on your calculator, and you're going to get some kind of negative value. Does somebody do this for me, okay? Inverse tangent, negative 4/3, b in radians.
Negative 0.927.
Negative 0.927. Thank you very much. Now, we want to use a negative 5 for r. So what do I need? I need this angle right here, which is negative 0.927. But is that in the range they want? No. How do we get an angle in the range they want? Add 2 pi to it. Go all the way around. Add 2 pi to it. Okay? That'll give you an angle between here and here. And use the negative 5. So what do you get? You got this angle with the negative 5 moves it up to here. It's a pain in the neck, okay? I'm not even sure how valuable it is either, but it's part of the homework, okay? So you got to add 2 pi to it to make sure it's in this range here, and use the -5 for your smaller r. That's what you got to do. Woo! Any other questions? Well, I'm working like a dog here. All right. Any other questions at all? Anything? On the test, homeworks, anything? Universe, question of the universe, anything? Anything?
I don't know.
A question in the universe? Go ahead.
All right.
I know it all. All right, go ahead. No.
Let me just get it up. This is the last question, 10.3.
Go ahead.
So that one was, once it loads, find the, I maybe we did this one, but find the arc length of a curve on the interval 0 to 2 pi, and then it says circle circumference x equals a cosine theta, y equals a sine theta.
I think I did do this one. I did a capital R instead of an A. But what do you have here? You have a circle of radius R. Okay, that's A. Circle of radius A. You can see that if you divide by A and square both sides and add them up, you're going to get x squared over a squared plus y squared over a squared equals sine squared plus cosine squared, which is 1. So you get x squared plus y squared equals a squared. Circle of radius A. So you know what the circumference is, okay? It's 2 pi r, it's 2 pi a. But we want to do it as an arc length problem. So let's take a look at that. We can do this. Oh, see that? Boy, wow, that's all right. I can do it this way. Okay. All right. Let's use the parametric form, the arc length. Now, I'm going to go from here to here. If we start theta at 0, x is a, y is 0. Start here and go to pi over 2. I will get 1/4 of this circle. What I want is the whole circle, so I'm going to multiply by 4. Okay? And then I'm going to use the parametric form, which is the square root of, take the derivative of this, dx d theta, would be a -a sine theta, and I'm going to square it. And the dy d theta is going to be an a cosine theta, so I'm going to square that, d theta. And
Where I got to, but
oh, good.
I wasn't quite sure how to do that integral.
Oh, let's do it. When you multiply this out, you get a squared sine squared, and you're going to have an a squared cosine squared. What do? You take the a squared out front as an a. Bring it all the way out front. It's a constant after all. And what am I left inside the radical here? A sine squared plus cosine squared. And what's that equal to? 1. Oh, Liam just gave me the finger. Oh, man. All right, that's a 1. All right? So you got d theta. I'm getting tired, I guess. I don't know what it is here. All right. Do you see this right here? Okay. Now, integrate d theta, which is theta. And now substitute in pi over 2. The 0 gives you 0. 2 goes into 4 twice. So you get 2a line, which is what we said it had to be. Bless you.
And that's the exact answer. I remember doing it.
Yeah. Any other questions at all?
Orientation?
Orientation. There's 2 kinds of orientation. You got the orientation with the conic sections like hyperbolas, up, down, left, right. But you also got orientation in the parametric forms where you set the parameter somewhere and increase the parameter. Is that the one you want?
Yeah.
All right, fine. Let's say you're given x equals t and y equals t cubed. And you want orientation of this thing. Okay. Well, since y is t cubed and t is x, you got y equals x cubed. So you got this as your graph. But the question is orientation, which, I shouldn't have put these arrows on the end here, but anyhow. When you start t at 0, you start at the origin here. And what you then do is increase the parameter. Let t equal 1. X would be 1, y would be 1. The orientation is such that it's going in this direction. Okay? It's going from lower left to upper right in this case. That's the orientation. You're more apt to get an orientation problem with something like, x equals, let's say, negative cosine theta, and y equals sine theta. Let's take a look at this one. Well, what you should realize is x squared plus y squared equals 1. You have a unit circle. You have a unit circle. And to find orientation, start theta at 0, say, in which case x starts at negative 1 and y starts at 0. You're starting here at this one, okay? Now, as you increase the parameter theta, what happens? Well, the cosine is going to decrease, but the opposite will increase, okay? So, for example, if you take theta equal pi over 4, the cosine is going to be square root of 2 over 2, but you got a negative there, okay? So x would be a negative square root of 2 over 2, okay? The y, on the other hand, as you increase the theta, the sine will increase and the y increases. So what happens is it goes around this way. The y will increase, the x will decrease, okay? I hope I said that right.
Yeah, I think so.
Oh, good, I hope so. Okay, so that's what we get. Theta equals 0. Yeah.
If not, I'll just blame you on that.
Oh, yeah, if you get it wrong, I'll just give you full credit because, no, that's what it is. Okay. Yeah, Liam.
Can you do something with the polar equation where you convert it to parametric form?
Sure.
I don't have an example.
Yeah, we can do it. Let's do a polar equation. If you have r is equal to anything at all, let's say cosine 2 theta. That's a rows of 4 petals, okay? Rows of 4 petals. And you want to and you have to find dy dx, okay? That's the slope of the tangent line. That's when you would use this, okay? That's when you would use this conversion. What you're going to have to do is take this polar equation and change it to parametric form, and then use the fact that we can find dy dx in a parametrically defined function by finding dy d theta and dx d theta. And that's what you've got to do. So given this, you should realize that x is equal to r cosine theta, y is equal to r sine theta. You have r is cosine 2 theta in this problem. So x is equal to cosine 2 theta cosine theta. You're replacing r with what's given. Okay, this r is what you got for your polar equation. And y is equal to r cosine 2 theta sine theta. That is now in parametric form, x and y in terms of theta. To find the derivative, use the chain rule. Ooh, and this is like nastiness here. Okay, because of the double angle here, you don't have the same argument. So you find dy d theta. You'd find dy d theta, it's a product rule. It's first times the derivative of the second plus the second times the derivative of the first. The derivative of cosine 2 theta would be a negative 2 sine 2 theta. Wow, this is really nasty. Over dx d theta, again, a product rule, first, derivative of the second, plus the second, times the derivative of the first. And it looks like you should have all kinds of simplifications, but you don't, okay? It's really nasty. The only one that wouldn't be so nasty is if you had to find the derivative dy dx at theta equals 0, say. Okay, let's let theta equal 0. Okay. At theta equals 0, that slope of the tangent line is equal to 1. That's a 0 there. Oh my. undefined. You get a division by 0, so it's undefined. All that means is you got a vertical tangent line at that point, okay? What can I tell you? Yeah, because what it is that, and it's this one right down here, perpendicular to the polar axis. All right, how are we doing?
Great.
Wow. Okay, Monday, what are we going to be doing? What's that? More? I'll take more questions. I'll take any questions you have on
Yeah,
Monday.
true, math club, that's right.
Math team, I got the pizzas coming in. Okay? Liam.
If you missed the first math team, are you disbarred?
No. Not at all. Math team on Monday, 12:15 in this room. 2 pizzas coming in. Drinks. Math. Thank you. Yes. All right. Have a good weekend. See you guys.